Hello everybody, myself Jyoti Mayekar and this is 17th lecture on atomic and molecular physics. So today we are going to discuss about Hund's rule. In the last lecture we discussed about electronic configuration and prior to that we already discussed about Pauli's exclusion principle. So let's talk about Hund's rule. Now and according to Hund's rule, uh, it states that the electron in an atom have a tendency to remain unpaired whenever possible. So we know that we have orbitals, and in those orbitals, the electron they occupy these orbitals in such a way that they remain unpaired. So, like for s orbital, we have the capacity of s orbital. It is of two electrons. So that is okay. One will be unpaired, and seven the second will be there. Though the two will pair. But suppose if we talk about p orbital where the capacity is of 6 electrons and we have 3 orbitals. For p we have 3 orbitals. So in that case suppose I have 3 electron, it will not happen that 2 electron will pair and 1 electron will be unpaired. They will not occupy that kind of a space. All the 3 electrons, as there are 3 orbitals, each electron will enter into one orbital and they will try to remain unpaired. They will not pair with each other. So that is what is Hund's rule all about. It means they have a tendency to have parallel spins because whenever the pairing takes place, one electron has a parallel spin, another has an anti-parallel spin that way. So here when the I have if I talk about p orbitals where I have 3 orbitals, in that case the electrons, they all the electrons which will be entering into the orbitals, all of them will have a parallel spin. Now we know that electrons in an atom they repel one another, and because of this repulsion, the farther apart the electrons, lower is the energy of the atom and greater is its stability. We know that when we talk about stability, energy should be minimum, and this energy is minimum when electrons are further apart. Now in completely filled shells and subshells, all the electrons are paired, but and in an unfilled subshell, electrons try to remain unpaired in different orbitals as far as possible. Now, we will take few examples, 2, 3 examples, and then this will become clear to you. So, we will take the simplest example of nitrogen. So, in nitrogen, we have 7 electrons. Atomic number of nitrogen is 7. We know that atomic number, it is nothing but equal to number of protons and number of electrons. So that means if I say nitrogen has atomic number 7, that means I have 7 electrons. Now, we have already studied how to write electronic configuration in the earlier lecture. So it is electronic configuration for nitrogen atom. It is given by 1s2, 2s2, 2p3. We know that the capacity for s orbital, it is 2 electrons. So you look at this 1s2, it is closed shell. 2s2, it is closed shell. Capacity is full now. So that means they are closed shells. So what I have is 2p3. Okay. So I have 3 orbitals. Suppose this is first orbital, second orbital, third orbital. Okay. I have 3 orbitals. And p subshell, that is L is equals to 1, has 3 orbitals. And or we can say ml is equals to 0 if we talk about in terms of magnetic quantum number. Ml is equal for L is equals to 1, I have ml is equals to 0, 1 and -1. So according to Hund's rule, the 3 electrons will enter into 3 orbitals with parallel spins. So first electron will go here, second electron will go here, third electron will go here. It will not happen कि एक इलेक्ट्रॉन यहाँ पे आ गया और ये वाला जो इलेक्ट्रॉन है इसने इसके साथ पेयरिंग कर लिया. Pairing नहीं हो रहा है because they have tendency to remain unpaired. And as all the 3 electrons are unpaired, naturally they have parallel spin. Okay. Now let us take the example of oxygen. So oxygen का atomic number 8 है. So it has 8 electrons, and we can write the electronic configuration as 1s2, 2s2, 2p4. Now यहाँ पे क्या हो गया, if we just have taken the example of nitrogen. Nitrogen में 3 था. So 3 electrons they entered into 3 orbitals. In case of oxygen हमारे पास 4 है. That means 1 electron is extra. Okay. So what is happening here? पहले तो 3 electrons, first 3 electrons they will enter into 3 orbitals, they will try to remain unpaired, but we have 4 electrons now, 1 electron is extra, so then that extra electron will pair with this electron where I have ml is equals to -1. As I have L is equals to 1, I will have ml is equals to 0, 1 and -1. And pairing starts from the lowest value of ml. So -1 se pairing start hoga. So here pairing has taken place. We know that both the electrons, they have opposite spin, right? Because we have already studied in Pauli's exclusion principle that no two electrons can have all the 4 quantum numbers same. So necessarily, if 2 electrons are pairing, they should have opposite spin. So that is how we represent it over here, and these 2 electrons are unpaired. Now let us take the example of iron. In Fe, atomic number is 26. We have 26 electrons, and if we write the electronic configuration of iron, we can write as 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Now all these are the closed shells because they are filled to their maximum capacity. Now here I have 3d6. P has 3 orbitals. D has 5 orbitals. So this thing also you have to remember that how many orbitals has. S के पास एक ही orbital होता है. P के पास it has 3 orbitals. D has 5 orbitals. F has 7 orbitals. So this is all this you should know. So prior knowledge of all these things is necessary when you apply Hund's rule. So when I say 3d6, that means I have 5 orbitals. So or you can remember it like d hai to my L value is 2. Like for S, L is 0, for P, L is 1, and for D, L is 2. If L is equals to 2, ml can take values from -2 to +2. -2, -1, 0, 1 एंड 2. इसलिए यहाँ पे मेरी 5 लेयर्स है. अगर वैसे याद नहीं रखना है तो दिस इज वेरी सिंपल एक्सप्लेनेशन. डी है, डी स्टेट है. डी स्टेट मीन्स L is equals to 2. L is equals to 2 है, that means ml can take values from -2 to +2. So बनाओ -2, then -1, 0, 1 and 2. So how many states are there? 5 states. Now how many electrons are here? 6 electrons. तो पहले तो फर्स्ट 5 जो इलेक्ट्रॉन्स है ना, दे विल एंटर ईच वन इन ईच ऑर्बिटल एंड दे विल ट्राई टू रिमेन अनपेयर्ड. फिर लास्ट वाला जो एक इलेक्ट्रॉन एक्स्ट्रा है 3d5 हो गया, उसके बाद में 6 है ना, सो 1 इलेक्ट्रॉन विच इज देयर इट विल पेयर विद द ml is equals to -2. लोएस्ट वैल्यू जो ml की है उसी के साथ पेयरिंग होता है. सो दिस एक्स्ट्रा इलेक्ट्रॉन विल पेयर विद दिस. सो आई हैव 4 अनपेयर्ड इलेक्ट्रॉन with parallel spins and 1 where the pairing has taken place. Now we know that here the unfilled, all the subshells, here you can see all the subshells are filled subshells. ठीक है. और D shell जो है, D subshell जो है, it is not completely filled because D का capacity 10 का है and I have only 6, so it is not completely filled. So unfilled subshell here in the case of iron, it is the D subshell. D subshell has 5 orbitals that we have seen, and according to Hund's rule 5 of the 6 electrons in 3D subshell will have parallel spins, while 6th electron it will have anti-parallel spin and it will combine or it will pair with the ml is equals to -2 value. So now here what do I have? I have 4 electrons with parallel spins which will contribute to the magnetic moment of the atom, resulting in a large resultant magnetic moment. Always remember one thing, that completely filled shells, ये मैंने last time भी discuss किया था, completely filled shells or closed shells, they do not take participation or they do not contribute in the magnetic moment of the atom. यहाँ पे देखो we have the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, ये सब है, but all these electrons they do not contribute to the magnetic moment of the atom because closed shells they do not contribute to magnetic moment of atom. यहाँ पे ये क्या है 3d6, it is not closed shell, it is unfilled shell because D का capacity 10 है, यहाँ पे सिर्फ 6 है. तो इसमें से भी वही इलेक्ट्रॉन्स कंट्रीब्यूट करेंगे मैग्नेटिक मोमेंट में विच आर अनपेयर्ड. तो ये तो पेयर्ड है, सो दिस विल अल्सो नॉट कंट्रीब्यूट. ठीक है, क्लोज शेल्स भी कंट्रीब्यूट नहीं करते और अनफिल्ड शेल में जो पेयरिंग वाले होते हैं वो भी कंट्रीब्यूट नहीं करते मैग्नेटिक मोमेंट में. only this upper 4 will contribute to the magnetic moment of the atom. So now here we know that in case of iron, I have 4 electrons which are unpaired, which are having parallel spin. So they contribute to the magnetic moment of the atom, and that results in a large resultant magnetic moment. And that is why we say that iron or cobalt, they are ferromagnetic in nature because it has a large resultant magnetic moment. So success of Hund's rule is it was able to explain ferromagnetism in iron, cobalt, and so on. So that's all about Hund's rule. I hope you have understood. Thank you so much.